All right, engineering students. Once again, we are meeting with Gil Addison at PathPoint, as you can see on his background. And Gil and I are just wrapping up our respective days, and it is time to show him what you both have been working on. So I'm talking to two teams right now. Remember, you're on one team, you watching right now, and then there's a bunch of others on a competing team. And we are actually going to choose the favorite, the most likely design out of this session right now. So pay attention, get your notebook out, take notes on what Gil says, because once we pick one, there's also going to be a lot of criticism, like constructive criticism, maybe some matching of the two designs. And I want you to have written down what he's looking for. Sometimes we get questions come back, and I feel certain Gil already said it, in the last video. So try to watch exactly what's happening here. Gil, do you have any thoughts for our boys and girls in the Engineering Academy before I jump into these designs with you?
Well, no, just good luck, and you guys all have great minds. So
yeah,
here it is, Battle of the Minds.
Yeah, excellent. Okay, well, let me share my screen. We are going to start. I'm not going to tell you anything about who these people are. You're going in this completely blind. But let's see. Let's start off with this one. Okay, can you see that okay?
Yes.
Okay, great. Let me just zoom in a little bit. All right, so I'll talk you through this, Gil, and then you can respond back to it. I want to explain so you understand what you're seeing. Mm-hmm. So this design is like a full desk, like building everything from the ground up. Clearly, freestanding, it can be moved anywhere. And this team went, This team went with the idea of having like a parallelogram sort of structure. Okay, so this can either be fully raised, and that would be almost actually kind of a standing height. In fact, if I measure with my tools here, that would be a 42-inch height. Okay, about 3.5 feet. So that's actually a pretty good standing height. And then let's see if this works correctly. We can actually grab it and it lowers down, and that would be its like, retracted or lowered height. That goes down right now to a height of 35 inches. And the height could be very much adjusted, by the way. This is just what it happens to be in this first iteration. And then on the front of it, they have a little separate like extra stand, and that I believe is where they wanted the keyboard to go. And it could have a little rail or Velcro or something to keep it from sliding. But that is the part that actually would sort of extend out into the person's lap, sort of in between the arms of a wheelchair, narrower in their lap, and the computer itself would sit on this upper surface and travel up and down with the desk. And I was working with this student today. What's driving this design in the middle, it looks a little bit like this. It's maybe not quite so thick, but it is this idea, is a mechanical actuator. So as that thing extends, that is actually what's bringing the desk down. And then as it retracts, that's bringing that back up. And that could have a little control pad it would have a little control pad that connects to that. It would probably be mains powered, and there would be, I think, a power strip mounted somewhere on the back of this for the computer to plug into, for the actuator to run off of. Materials wise, they've kind of gone for, looks almost like a metal and wood design. More likely it would be all wood, I think. It's a little easier to manufacture and produce and purchase. But yeah, I think that's the overall design. I think it's pretty clear, it's pretty clean. So we welcome your thoughts on the merits and the maybe problems with this design.
I like it. It's I like the tilting forward. Is there so the computer itself can will kind of tilt forward like that. So if somebody was in a low wheelchair and they were looking up, they could still see the computer like that. How about is like a safety mechanism, like for the whole pinching and things like that? kind of out of the way.
Yeah, that is a great question. That is something we have been bringing up the whole while. Like, this has got to be safe as well as functional. So as far as kind of like a collapsing hazard, because that's always a problem with folding or movable furniture, this actuator is has quite a lot of internal friction as it drives. It actually drives very slowly. It's like,
Okay.
and so because of the internal friction, this desk won't slip or change from whatever height it gets set to.
Mhm.
There would be potentially, as it stands right now, maybe kind of like a pinching hazard was what you described. So yeah, as that comes down, that would be something to be mindful of. I think the way around that would be to probably put actually some spacing.
Yeah.
You kind of put like some nuts or a bunch of washers or spacers so that these struts actually have a significant gap,
Mhm.
like that edge and that edge right there. That would create a gap so that no fingers or cords or anything would be hurt. So I think that would be pretty doable, actually.
Yeah, I can see that, or something that might come off the edge and kind of cap off the
Okay.
side, something like that.
Yeah. Yeah, actually, those struts could also be repositioned. The desk underneath could actually be narrower than the
Mhm.
one above, and all of that mechanism could be completely under the upper surface, sort of
Mm.
partially kind of hidden.
Okay, I like that. I like the keyboard idea too. So that
Mhm.
it comes out.
Yeah.
Um, it like a safety button could there be like a little safety button that you can just press the red button and it stops everything instantly?
Yeah, I think it would likely be that as you held down a down button, it's lowering. As you held the up button, it's raising. I think like
Okay.
as soon as you let go, it would stop moving. That seems like the most intuitive, safe design, and I believe that's what the control pad that comes with these kind of actuators looked like when I saw it.
Okay, cool. Yeah, one thing to take note of is the individuals that we support. Some of them, the reactions, the time it takes for them to push something may take longer than other individuals. So
Mm,
just the range of motion to get there may take a little bit more time to press. So that's always kind of a thing
yeah,
that I'm always considering is like how much time does it take them to
yeah,
press the button,
yeah,
and do they have the strength to press it in?
yeah,
These are just little things that I'm always thinking about.
yeah,
Um,
yeah.
so,
Great question. And here's another question I guess I have. Um, Again, I think it's something that would be solvable, but say if the person in the wheelchair, comes up to the desk, it's in standing position, they want it down, where is that button touchpad located in a way that they can get to it immediately, but they're
mhm.
also not going to be like crushed under the desk as it comes down on them. Not that that would happen, but you know what I mean?
Yeah,
Yeah.
that's a good question, and it might just need to be. Hmm. It could be part of the keyboard pad because
Mhm.
since that piece already comes out, it could
Yeah.
already be a part of that. So they
Yeah.
just kind of drive up to it, press
Yeah.
it, and another thing I've seen in the past or in some of the desks is that the desks actually have like numbers 1 through 4, and you
Mhm.
can program those numbers to be specific heights for certain individuals.
Yeah. Yeah.
Yeah, I thought
And
that was
even
really
for
cool.
programming. Yeah.
Mhm.
Yep, that would, I'm sure something like that would be available and possible. Um, and one thing else I'll say too, I think it'd be worth thinking more about this little keyboard desk, because that could actually be made to be significantly either further out and
Mhm.
lower as well.
Yeah,
As this thing comes down, it really does go right down into the person's lap. Because
yeah.
right now it's not. I think it feels like it'd still be kind of up here with your fingers. So plenty could be done with that. Okay.
Yeah.
Well,
Great.
I think I'll switch over to the next design. I think that gives us a really good one to start with. So good job, team. Let's change our screen share. to be this one. Okay, now this is definitely just a different kind of design altogether. So this team decided to pursue the idea of attaching like a desk modifier or like a desk attachment onto an existing table or desk that you would already have in hand, which makes sense. Tables are everywhere. So this is sort of like a sturdy base that has some sort of clamping mechanism on the back, and there's a lot of ways that could be done. There's a lot of simple, safe, elegant ways, and then these guys didn't model that actuator quite as intricately, but that's what this cylinder here is some kind of like pump sort of actuator, just like the previous one, but at a shorter length this time. And that gray block there is the computer. Looks a little bit like the old Macintosh, the black and white Macintosh I used to use in middle school.
Yeah.
Very like chunky. And then here's the keyboard. And so this one, the person comes up while the thing is in like kind of a flat position. And then again, they operate a little button or something, and it slowly lowers to whatever angle and height they want. So in this case, you're creating an inclined surface. So we would ensure that the computer was very firmly attached, which is completely doable. Again, the keyboard would have to be Velcroed or bolted down in some way. And then we talked about how the geometry could really be controlled pretty well. Like how far out is that shelf that extends? Because the further out you make it, obviously the lower it dips down into your lap. So you just play with that length until it feels pretty good. And yeah, it's just a simple hinge. Again, this would move very slowly because of the actuator driving it. So yeah, let's get your thoughts on this one.
Yeah, I like it. I like the idea that it's like it's kind of portable. You can detach that and attach it to another table. So you could go and attach it to a lifting desk that's up, rises down. So you can add that in the future. I like that it's that it does tilt forward, and that the keyboard is spaced out nicely for somebody in a wheelchair just to kind of go underneath that keyboard and have it in the palm of their lap, or however high they want it, or in specific positions. Yeah, this one's this one's kind of cool. I like.
Yeah, and it looks like these guys maybe mistakenly designed in inches, but I was going to say I think each inch stands for a foot, but maybe that's not the case. So yeah, it's a little hard to tell dimensions directly, but like I say, that could be controlled. One, a couple of things I see here. In the way it is right now, this seems to be a little bit of a potential tipping hazard to me.
Yeah.
You really want to be careful as to where, like how far out the hinge was. The hinge actually could be all the way right back up to the edge, back up to this edge of the table and still achieve its purpose.
Yeah.
And I think as long as the computer was always over the table surface underneath it, I think that tipping hazard becomes less and less.
Yeah, more centered in the centered.
Yeah, more centered over the four legs of the table underneath. Because right now it looks like it wants to fall at you, which we absolutely couldn't have.
Yeah, you do have the weight of the actuator too to kind of counterbalance.
Yeah, they are probably only in the order of like 2 or 3 pounds, I would think.
Okay.
Not terribly heavy, but yeah. And I was also talking to this team too. I think a more realistic place to put the actuator would actually be kind of spanning these two sort of regions right there, right across the back, as opposed to underneath like a jack, But if you think more like a slightly longer, more spindly looking thing than this thicker cylinder that they've modeled. And then, yeah, that back would keep it really far away from the user.
Mm-hmm.
I think this one probably does a little better in terms of like pinching hazards.
Yeah.
Not a lot of like moving parts proximate to the user.
Yeah.
Although all
How
this one
wide
does,
is it?
what's that?
How wide is it?
Well, it can be as wide as it needs to be. Right now, as I say, it's a little hard to read their dimensions. It says 3.88 inches.
Okay.
That's obviously not accurate.
Yeah.
So, you can sort of tell it looks like about twice the width of a computer or a computer keyboard.
Mm-hmm.
But it could be completely controlled. It really only that front tongue really only has to be wide enough to accommodate the keyboard and maybe a mouse.
Yeah, keyboard and a mouse would be great there.
Yep. Yep. So, I think of my own computer, I think 18 inches, a foot and a half,
Mm-hmm.
that would feel about right.
Another thing we use like for our, as assistive technology for controlling a computer is the new Apple trackpads. Those
Okay.
are really cool because they're touch sensitive.
Mm,
That's another thing that we use for
okay.
for a mouse.
Yeah. That's like that kind of like silvery plate,
Yeah,
right? Yeah.
probably about, you can't really take measurements, but it's probably about 5 to 6 inches long. Like, I
Yeah.
don't have one in front of me, but
Yeah. I think I've seen it. It actually looks a little bit, I guess, kind of like this right here. Yeah.
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 So a trackpad and a keyboard.
Uh-huh.
And then like sometimes like what we do is like we'll use not just your standard Apple keyboard, but we'll use a larger keyboard that has bigger buttons for individuals. So we kind of swap those out. So if the base could be wide enough to accommodate one of those keyboards, they're probably about a foot long, maybe a little over a foot.
Okay.
That would be cool.
Yeah.
Or maybe just kind of shape the actual tilting piece to kind of accommodate a keyboard. So coming down and then making it a little wider at the base. And ideas.
Yeah. And I think as I think of like criticism of this design, seems to me like a lot of the material in this back area is kind of like wasted, or like not really necessary, it looks like.
Mm-hmm.
It might be a little over design in the back. Like really what you need is to be able to hold that computer in place.
Yeah.
So, with more accurate dimensions of what the iMac looks like, and how it will touch down, all that can be controlled. I also advise these guys to only bother putting a clamp on the back, because the kind of weight distribution and using this, like the load is really kind of here on the front. And so it's only going to really try to pull up on the back.
Mm-hmm.
That's where you clamp it. And then at the front on the front edge of the table, it's just kind of going to press down anyway. It's not going to go anywhere.
Yeah.
And there could be little like rubber pads underneath to help it grip and not slide around.
Mm-hmm. You could make the clamp out of lead.
Right. Yes. That would be nothing to provide some counterweight at the back.
Yeah.
Yeah.
Lead might be too heavy though, but
yeah, I would say that there's a few ways you could do the clamping. It could be a very simple, like almost like a wooden hook that just goes around the desk. It could be like a wing nut bolts screw, like two wooden plates that just kind of clamp together that way. But whatever you do, you could provide more weight at the back to help stabilize.
Yeah, I think. All right. Well, I mean, you could also, some additional things like for like the back there, maybe a power strip back there, maybe something that's like that has all like the cord management there. So all you just plug in is the computer. If you have some speakers, plug those in.
Yes.
Cord management. Cord management is really kind of key too. especially if you have a wheelchair, because again, like you don't want the wheelchair foot pedals to pull on a cord, and then next thing you know, you're backing up an electric wheelchair and everything follows you.
Everything follows you. Yeah, yeah, yeah. It's safe to say that both these designs would have a built-in power strip,
Mhm.
because at the very least the actuator needs power.
Yeah.
And then yeah, obviously all the computer and everything, for sure. Yeah, and I think it was these teams. I think one of these teams, I forget which one, was looking into like there's kind of like almost a little wire basket tray that
Hmm.
can sit on the back of desks that you can buy as a standalone item, and just does kind of like hold all the slack of different cables and cords and things.
Yeah, I have one of those under my desk. It's like a little IKEA baskets.
Yeah,
You just put all your stuff in there.
yeah, yeah. Okay, great. Well, I don't want to take up too much more of your time. This has been really valuable, but I would love for you to, yeah, I'm going to stop the share. I'd love for you to tell me which one of those two um, we had the sort of parallelogram design
Hmm.
to begin with, and then we had the one that we were just looking at. So I don't know, which one do you think has more chance of being useful and safe and actually implemented that would help someone?
Yeah, well, the what's interesting is I've been just kind of going back to my CSUN record for assistive technologies and things, and our professor brought up like these 3 points that he always kind of goes by: is the product usable? Is it accessible? And is it functional? And so these were kind of three key things that just kind of rang in my ears looking at these types of devices. I really like the way that um, the table, the first desk looks,
Brown one.
and then I also like the other desk because it's portable, and then you could just move that to a different table. You could in the future, maybe that table just gets banged up and damaged, and you need a new table. You just move it over. Um, what if there was a way to take that idea and combine it with the other, and so
Mm.
you use those same type of mechanisms of being portable, and
Mhm.
then using
Mm.
that first design to just kind of bring that onto a table, that same type of design.
Mm.
I'm seeing these types of things.
Yeah, yeah. And don't feel you have to please everybody, Gil. Like it's okay for there to be a winner and a loser, but I but I definitely hear what you're saying. So you're saying like what if we had those two brown parallel layers,
Hmm.
but that was the thing which sits on the desk with the clamp at the back.
With the clamp at the back,
Yeah,
yeah. Taking that idea from the other design and bringing that
yeah,
in this idea.
yeah.
Um, why I would widen the keyboard location, and then I like your idea of making it extend out farther and maybe tilting a little,
Yeah,
or rising up and down.
yeah.
That's a great idea.
Do you think would it make sense to make that keyboard extension part, should that be adjustable? You know, like I can kind of imagine like a screw. I'm losing the word, but like a big screw adjustment where it could like rotate and like lock into a different position, then you tighten it back down again, or just a fixed, safe, set piece.
yeah, like a screw adjustment. That makes it just easy,
Mm.
right? And so that makes it more universal to just kind of,
Mhm.
okay, you're going to set this up for this one individual, just
Yeah,
unloosen it, tilt it a bit, set
yeah,
it where it needs to be set, tighten it up, and you're good.
yeah,
I like that idea.
yeah. Okay.
Um, they're both great ideas. I
Yeah.
really I love this desk here. I think this is kind of the go-to
Okay.
for me. Um, but I love that other idea too. So making
Yeah. No.
combining those together really
Yeah.
refined it, and it does make it a. It's like it does you know it does answer all those questions. It's accessible because it's movable in such ways. It's functional because you can move it from desk to desk,
Yep.
and it's usable. It's like something that you could always have. You can move it to different locations, and
Yeah.
it's going to work.
Yeah.
So Yeah.
Okay. Well, cool. I think we have our answer then. It's a bit of a hybrid of the two.
Mhm.
So this design for the motion, but the idea of the portability and the desk attachment instead of rather than building a whole desk. So I love that. And I totally agree with you. I think I really like that we got two genuinely different designs as well. They didn't just converge to the same place, but we had two honest to goodness different things, both with their own merit. So
Yeah,
excellent.
definitely. I think kids patent your ideas.
Yeah,
Assistive technology right now is really kind of evolving. The parts to build assistive technology is getting a lot cheaper.
yeah,
Um, and then just being able to build something like this for an
mm,
individual with a disability can really change the outcome of
yeah,
how well they live in life.
yeah,
You know, it's a long,
yeah,
it's hard to explain. I've seen it happen, but to be able to provide something like this at a home for a person who wants to run a business but needs that specific desk
yeah,
like this, yeah, there's some great potential here.
yeah,
Um,
yeah.
you got a great class there, Rodney.
I know it. I know it. Absolutely.
Yeah,
Completely agree with you. Yeah,
yeah.
yeah,
There's things that I don't see that you guys see.
right,
It's pretty amazing. So
right.
thank you guys. Thank you all.
For sure. Well, thank you, Gil, for your time. And I think that gives us enough direction to keep on moving forward. So we will probably reconnect with you. Like we're going to assign all students now to this new design path. And, we've been meeting together approximately once a month. So
Okay.
probably meet again sometime in December.
Sounds
And I
good.
do hope to start building maybe in like late December, January, and delivering after that. So,
Excellent. Well, you guys all have a great holiday and stay safe. Thank you all for what you guys are doing. It's just like incredible, incredible minds. So,
all right.
all
Thanks.
right, you ready?
All right.
There you go.
Just stop. Oops, wait a minute.